everyone. This is the third chapter of the programming concept using C++ programming language, and in this chapter we are going to talk about the control structures of the C++ programming language, or the programming languages in general. So the first thing to be talking about is the Boolean and logical operators. So what do you mean by that? We have a data type in C++ programming language which just can hold only logical data. Whenever we are saying logical data, we refer to only two values. What are those two values? True and false. So you may be familiar with the logical values, which there are only two values, zeros and ones. And so in the Boolean data type, we've got a logical value which is going to be true or false, or it's going to be 1 or 0. So when those true and falses are going to be converted to ones and 0 when we are doing typecasting. So when we are casting a type from boolean to integer, the true is becoming 1, the false is becoming 0, like this one. For example, this example, int number, we've got this variable which its type is integer and the name of the variable is number. Number equals to 2 plus true. So this true is a boolean value, but we are adding it to an integer value and holding the result in an integer variable. So this one is considered as 1. Okay, this true is considered as 1. So like this one, true is 1. 1 plus 2 is going to be 3. So the number is going to be 3. See out number, the output is going to be 3. And the typecasting from integer to bool, what happens here, the 0 value, like this one, if the value is 0, it is considered as false, and non-zero values are all considered as true. For example, if you got 0, it is false. If you got 1, 2, 3, minus 1, minus 2, minus 3, any other value is going to be considered as true. Only the 0 value is considered as false. For example, we've got bool b equals to false. So we've all initially assigned the b to false. So this variable b, which its type is bool, is false, and we are saying integer number equals to 0. Now we are saying b equals to minus 10. B was false, or was 0, as we said here. Now we are reassigning it to minus 10. So at this time the b is becoming true. Okay, the b is becoming true. Why? Because it's a non-zero value. And here we are saying b equals to number. We are reassigning it again to another number. And what is inside the number variable? This one, 0. So whenever it is 0, any boolean variable is 0, the result is going to be false, or it means false. When it is non-zero value, it is true. So this is the boolean and logical operator, which can hold only two values, like this one. The data type is bool, and then we are naming the variable name, and whenever it is true, that means it's logic 1. Whenever it is false, that means it is logic 0. What would be printed by this code segment? Let's explain this one. Bool b int p. So the b is boolean and the p is integer. We say integer q equals to 5. We've got those three variables. B equals to q. We are assigning b to q. So how much was b? We didn't give it any value, but we've given q a value, which it is 5, and we are saying b equals to 5. Okay, now b is what? B is true, or is what is logic 1. So it's true, so it's going to be converted to logic 1. And we say integer p. We've already said p is integer. P equals to true. B didn't take the 5, so we say b equals to 5, but it's going to be true. Okay, and we say p equals to b. B was true, so p is going to be true, or it's going to be 1. It's not going to be 5. Why? Because we cast the type from the boolean to integer. So the value of p is p variable. What is inside p? B. What was b? B was true. So what is going to be printed? 1 is going to be printed. So the value of p is this variable, the content of this variable, which is 1. And here we are talking about the logical operators truth table. We've got a not in logic. If it is false, the complement is going to be true, or the result is going to be true. True is going to be false, like this one. If x is 0, the output is going to be 1. Is non-zero, the output is going to be 0. So this is in logical, this is in C language. And in AND logical operator, both inputs or both data must be true, then the result is going to be true. Otherwise, the result is going to be false. But in C language or C++ language, only then two non-zero values are going to be 1. In the other cases, the output is going to be 0 when we are ANDing them together. In OR it's going to be written on those two lines. So only when the both values or the both inputs are false, the result is going to be false. Otherwise, in all the other cases, the results are going to be true, like this one. If you've got two zero values, the OR of them is going to be 0, or the result of OR of them is going to be 0. Otherwise, in all the other cases, the result is going to be 1. Yeah, this one is important in programming language when you have two conditions together. If you have a false condition and anything, the result is going to be false. Why? Because we said here, when the result of AND is going to be true, when both conditions are true. But in this case, at least one of them is false, so the result is going to be false. And but in OR, whenever, if only one of the condition is true, one of the option is true, the result is going to be true. So we don't take this one into account. When this one is true, so this one is going to be true, maybe going to be false, whatever it is. So but we don't take it into account. The result is going to be true, but in this one the result is going to be false. Why? Because in the AND, both of the conditions must be true, then the result is going to be true. But in the OR, if only one of the condition is true, the result is going to be true. The relational operators, so we've got those operators in programming language, and let's say what are they meaning. So this is the less than. For example, if this value is less than this one, if this value less than or equal to this one, if this value is greater than this one, if this value is greater than or equal to this one, if this value equals to this value, if this value not equals to this value. So this is very important, those two, and or even the others are very important, but you need to know if you want to compare two values, if they are not equal, what are you going to write down? This one, this escalation mark, and this assignment put together in order to refer to non-equality meaning. Let's take this example. Int a equals to 10. So you are saying cout a. So it's going to be printed 10 because the value inside a is 10. And we say cout a double assignment to 1. This is going to be a comparison. It's not going to be an assignment. So it prints 0. So it checks whether it's false or true. It's a condition. Cout if a equals to 1. Is a equals to 1? No, a equals to 10. So this is going to be false. This what is inside this is false. So 0 is printed. So cout a greater than 1. So what is going to be printed here? It prints 1. Why? Because 10 is greater than 1. So this is true. Cout a equals to 5. What is going to be printed? 5 is going to be printed. Why? Because this is not a relational or a condition or stuff like that. This is an assignment. This is not a logical expression, it is assignment. We are assigning a to 5, so what is going to be printed? 5. And in this one, a equals to, if a not equal to 5, what is then see out a, what is going to be printed? 0. Why? Because we are assigning this a to this condition. We've already said set a equals to 5, and we are saying if a not equal to 5, no, it is what? It is false. So this is going to be false. This is going to, a is going to be 0. So whenever you are saying see out a, what happens? It prints 0. Why? Because 5, this one 5 not equal to 5, so it's going to be 0. Or in the other words, we have said a equals to this condition, and this condition is false. Why? Because we are saying is a not equal to 5? No, a equals to 5. So this is false, and this a is going to be false, or it's going to be 0. So it prints 0. Logical operators, complements, for example, if we say less than, the complement is going to be greater or equal. If we say greater, it's going to be less than or equal. If we say if equal, the complement is going to be not equal. This is not equal. And another way, in order to complement an expression, we need to put this exclamation mark in front of the expression itself. For example, we are saying if n equals to 0, and its complement is going to be n equals to 0, but we are putting this exclamation mark in front of the expression itself. And here it shows how to use that complement. For example, in this flowchart, we say if n is 0, so do nothing. If it is yes, do nothing. If it is false, print the number. So it prints all those numbers which are not 0. But how to take the complement? We can say if n is not 0, if n is not 0, if the value is not 0, print it. Else doesn't. If it is 0, doesn't do anything. So whenever it's true, print it. If it's false, do nothing. So this expression can be written like this one, and even can be written like this one. It doesn't matter. And this is another example. Number is 10, and print number is going to be number minus 1. Decrement the number by 1. Is number is less than 1? No, it's 9. Okay, so this one is not true. So the false part goes back again and prints 9, and the number is becoming 8, and this one is false again. So, and it repeats until the number is becoming 0, then it goes to the end of the flowchart. But mostly the iteration part must be in the true condition. So what are you going to do? We are going to take the complement of the condition. So you can say if not number is less than 1, or the number is greater or equal to 1. So what happens? Number is 10, print number is going to be decremented by 1, number is going to be 9. Is 9 greater or equal to 1? Yes, it comes back again. It becomes 8. So it becomes 1. 1 is greater or equal to 1? Yes, it comes to back again to print the 1, and then the number is going to be 0. 0 is greater or equal to 1? No, false. It comes to end to the flowchart. So sometimes when you are writing your program, you may face some logical choices. You may face some point that you need to decide one of two options, or one of more than two options, or choose only one option among some options. So what is going to be? So for example, if you say if the score is higher than 50, that means the grade is pass. Else if it's not greater than 50, what happens? The grade is fail. So what are you going to write in C++ programming language? We say if score is greater than 50, that means grade is pass. Else what is going to be? The grade is going to be fail. So if this condition is true, come and do or execute those statements which are in between those two brackets. Else execute those statements which are in between those two brackets. And we are going to learn the syntax of C++ or of if condition in C++ programming language in the upcoming